All right, thank you so much. This is the title of my slide. Where are my nodes? It's something we wonder every day. The first thing I wanted to say is to just say thank you. It's been 5 years, more or less, to the day since this original idea occurred to myself and Joe and Craig in Seattle. How many people are going to join us in Seattle? Yeah? All right, it's my hometown, so it has a special place in my heart. But to think that 5 years later we'd be here in the first KubeCon in China, all of you coming here to talk about Kubernetes, and more importantly to base your businesses or your projects on top of this software that was really just an idea is incredible. And I just wanted to say thank you, and also thank you to the community, because honestly, I feel much of the time that, you know, we threw a little pebble and the community took it and turned it into this amazing sort of boulder that's rolling down the hill. So thank you so much. It's really been an honor. And so when I started out, I always used to ask a question, and I would ask, you know, how many of you heard of containers? And I don't think I need to ask that question anymore. And even now, I used to ask how many, you know, have heard of Kubernetes, and I think I don't have to ask that question anymore. And that's really great. So what I'd like to ask instead is, how many people out there are using Kubernetes in production today? All right. How about on-prem versus in the cloud? A little bit of both? All right, cool. How many people are running Kubernetes in China? A couple people out there. Awesome. Awesome. Well, thank you so much, everybody who's doing this, and I hope in a year or in 9 months when we come back to Shanghai, we'll see more hands and from the things that you've learned today. Well, as I said, I'm going to talk about serverless Kubernetes. I'm going to talk about some ideas about the future and where I think we may be headed. I wanted to start by talking about where we came from and what the role of the Kubernetes API and the Kubernetes project was intended to be. Really, from the beginning, we had this notion that we were going to be transforming cloud-based APIs from being focused on physical things, virtualization of physical things, virtual machines, virtual networks, virtual whatever else you want to add after the end, to more developer-oriented, application-oriented primitives. And so the Kubernetes API is really intended to be an application-oriented API. But the truth of the matter is that the machines were still there. And as we built the API, we actually did a lot of thinking about the machines. But I think that in doing so, we didn't really hide the machines. We just sort of made them someone else's problem. And that's, I guess, a step forward because it allows operations to separate and to focus on machines or to focus on the application. But in reality, I think that what we really want to be thinking about is how we move towards a world where the machines are gone, where from a Kubernetes user's perspective, you really don't ever think about the machines. They really are not a piece of the things that you think about. And so hopefully for the rest of the talk, I'll give you an idea about what that looks like, how we might get there, and what some of the challenges and open questions are. Because the truth is that although the API was built to give you this application-oriented perspective, this API that was focused on your containers, your distributed systems, and not on your nodes, the nodes are still very much there in Kubernetes as it stands today. They are deeply embedded in some ways into how the architecture of the system is built, and teasing that apart so we can get back to that world where the nodes really are not something that you see is going to take some effort. The goal behind that effort, of course, is to build a serverless Kubernetes. Right? Serverless is sort of, I guess it's the latest word to become hip. It was, I don't know what it was before DevOps, but it was DevOps, and I guess service-oriented architecture. That was one of maybe the first like buzzword compliant words that I heard. You know, these words become more than the word means, I guess, at some level. And I think it's important when these words become kind of these amorphous, ununderstandable things, it's important for us to take a step back and actually say, like, when we say this word, oh, container was there too. People would say container and it meant all these different things. What does serverless really mean? And I think when we're thinking about serverless, it's important to think about, are we talking about a programming model? Are we talking about how do I take my code and get it into the cloud? Because I think in some ways, because it was the birthplace of serverless, functions as a service has become very, very closely tied to the idea of serverless. Or are we talking about taking containers and running them in a world where there are no machines, where the server is gone, where there truly is no server? And I think distinguishing between those two very different use cases is an important first step in how we think about how we bring serverless and the concepts behind serverless to Kubernetes. And in fact, we can have a serverless Kubernetes API today, right? When you use a managed cloud-provided Kubernetes, the Kubernetes API is effectively serverless. You don't see the master nodes that are responsible for the API server. You sometimes don't even see the processes themselves that are supplying the API server. You're starting to consume the Kubernetes API as a serverless offering. And that's great, because it means that you don't have to deal with management, you don't have to deal with the complexities of upgrading, you don't have to have an SRE team that is responsible for keeping that cluster alive. There's a whole bunch of simplifications that allow you to focus on your application that you're building on top of that Kubernetes API. But serverless has a bigger meaning than that. It could mean I'm having a serverless database. You know, I can hide the applications themselves, the implementation of them, especially with storage, behind the same kind of managed interface. And likewise, when I'm thinking about programming models, I can lay programming models on top of Kubernetes. Right? So I think this is why it's so important to distinguish between serverless where the machines are hidden, serverless where you don't have any operations, from a programming model that makes it easy to get your code into the cloud or easy to get your code into a particular cluster. So when we're thinking about the Kubernetes API, we can have containers laying on top of that Kubernetes API, and then we can have functions as a service as a programming model that lives on top of those containers. We can have the Helm package manager, which is a programming model for deploying distributed systems that live on top of those containers. And so when we're thinking about how people bring those, what have been called serverless programming models into Kubernetes, they really are services that are built on top of that Kubernetes API. And honestly, this is about all that I'm going to talk about in terms of programming models, because I think, while it's interesting to explore how we build up these levels of abstraction on top of the Kubernetes API, it actually doesn't require very much from Kubernetes itself. They take the API as is, they build up from it, they provide new programming models, and developers hopefully are happy. So I think the more interesting question is, how do we deal with serverless infrastructure? So serverless infrastructure looks like this. In a more traditional model, you have a container, and it's running on a machine. Maybe it's a virtual machine, maybe it's a physical machine, but it's running on a machine, and you are aware of the machine that it's running on. In most cases, you're managing it. Sometimes someone else is managing it, but you're very much aware that there's a machine there. As opposed to the notion that you can have a container, and it is the only thing you think about in the cloud. You say, hey, cloud, I would like you to run this container. That's the extent of my infrastructure. I don't see any other infrastructure in the cloud except for the containers that I choose to run. And so I think this notion of serverless infrastructure, serverless container infrastructure, is something that's becoming increasingly popular. We see all sorts of different versions of it popping up in various public clouds. And so if this is the building block, if instead of having virtual machines, we have serverless containers as a building block, how do we make that go and work with this Kubernetes API that has been built with nodes that are underneath? I think the first thing to consider is that Kubernetes actually supplies a wide variety of different tools to different people. And in particular, what I want to draw a distinction between is I want to draw a distinction between orchestration and scheduling. And I think most people, when they're thinking about Kubernetes, they're actually consuming the orchestration APIs. They're consuming an API like schedule job or cron job that runs a container on a particular schedule. They're consuming things like service load balancers that create cloud load balancers and bring traffic down to their containers. They're consuming things like replica sets that replicate containers out into a prescribed number or even are auto-scaled in response to load. Or they're thinking about something like a deployment that is busy moving from my green container image to my blue container image, or from V1 of my software to V2 of my software. These are all orchestration APIs, and what's important to note about all of these APIs is that they are basically divorced from nodes. There is really nothing in any of these APIs or users' usage of these APIs that knows anything about a machine. As we'll see later, there are some concepts like like affinity and colocation that describe some of these containers, but again, they're describing relationships between containers. They're not describing specific relationships to machines. Whereas scheduling is another very important part of Kubernetes, and it is focused very directly on how do I take a container and which machine should I place it on. Right? And so these are sort of two personalities, two pieces of what it means to be Kubernetes. And I think as we move towards this serverless infrastructure, it becomes very clear that the scheduling part is the part where we have to do some thought. Because the orchestration APIs, I believe, are the place where people are interested. That's the use case that the end user is interested in. Scheduling happens to be an implementation of those APIs, but in a world of serverless infrastructure, the scheduling may not actually be something that Kubernetes is responsible for. And so when you think about nodeless Kubernetes, the nodes disappear, the scheduler in many ways disappears, and you're left with the orchestration APIs and serverless infrastructure to run your containers. So what we're doing is we're marrying this up with that serverless control pane that's already in the cloud. All of the clouds have already figured out how to run a serverless Kubernetes API. And so as a community, we need to say, how do we then take that and marry it up with serverless container infrastructure that the clouds are also busy building? And in particular, it's important because we want to provide the end user with the same experience, the exact same conformant Kubernetes experience that they could achieve when they saw the machines. Hopefully, we can get to a place where it can also be achieved when the cloud has taken those machines over. And this is especially important when we think about portability, when we think about hybrid cloud, where a user may be running physical machines on-premise. It's very hard to take physical machines and make them serverless. It's only something that can be present in the cloud. And so when we think about Kubernetes and how we bridge these gaps, it has to be a conformant Kubernetes. It has to be a Kubernetes where an application runs exactly the same, whether it's running on physical infrastructure, where the nodes are very much there, or it's running in the cloud, where it's truly serverless. And the experience has to be maintained. And likewise, things like service load balancers need to function correctly. Things like logs need to function correctly. The entirety of the experience of Kubernetes needs to stay consistent. So how do we think about doing this? Sorry. First time through this deck. I think what is interesting, however, is those same orchestration APIs are extremely useful for other things that might not traditionally have been considered Kubernetes nodes. In particular, deployment knows how to do a rolling update with health checking and pausing and other sorts of safety guardrails from one version of software to another. Well, it turns out when you're deploying things to IoT devices, that process is very, very useful. So how can we take that orchestration API that people know how to use, that is beneficial to them in a world of running reliable services, and bridge it to IoT, right? Clearly, the IoT device is never going to be a node in the Kubernetes cluster, and in any real sense of what Kubernetes thinks about when it thinks about nodes. So when we start thinking about nodeless Kubernetes, we start opening the door to these kinds of use cases. Right? And that's an awesome thing. Actually, it's an unanticipated thing. And so one of the things that I love about being involved in this community is you start talking about ideas and you inspire others to think about new use cases for those ideas. And so nodeless Kubernetes, when we started, was very much focused on serverless infrastructure. And then the IoT folks who we talked to came along and said, you know what? That orchestration API you have would be great for deploying to IoT too, and we're now moving forward with them. Finally, it actually allows you to bridge the gap to other kinds of nodes. The kubelet itself is very tightly bound to Linux and now to Windows as well. If you wanted to bring it to a FreeBSD, if you wanted to bring it to another kind of operating system, you could actually use that as effectively a virtual node into your Kubernetes cluster as well, because you don't have to deal with the operating system details, the machine management details of what the cluster looks like. So hopefully at this point I've painted you a very beautiful picture and we can all go out and execute into the serverless frontier, right? Well, unfortunately, it's not quite that way, right? There's a lot of open questions that we need to answer, and I think importantly, there's a lot of open questions that we need to answer together as a community. And so to give you an idea for the flavor of this, I mentioned earlier about scheduling. Where does the boundary of scheduling lie in a world of serverless infrastructure? Clearly, when there are machines there, we have a scheduler. It's responsible for things like affinity. It's responsible for placing, two containers on the same machine or spreading two containers across two different machines. In a world where the machine isn't there, what is the job of the scheduler? Do we want to just pass constraints down into serverless infrastructure and have the serverless infrastructure take care of those constraints? Do we want the serverless infrastructure to expose some details about how it's implemented? We've seen the same concerns happen in the cloud, where clouds have had to surface some details about, well, perhaps what rack or what power domain is this particular virtual machine running on, so that Kubernetes itself can actually understand the failure domains that are present in the cloud. I think this is an important area that we're going to have to continue to consider as we go forward. Similarly, with networking, a lot of the serverless infrastructure, how do you do DNS? How do you do all the IP tables work? How do you do all of the things that make services and proxies work inside of Kubernetes? These are going to be important areas that we're also going to need to explore. And the good news is we're starting to explore these ideas. Right? We're starting to explore these ideas in the context of the virtual Cubelet project. It's an open source project up on GitHub. It's been around for about a year. It's worth noting this is not the only answer. There are other options for building a nodeless Kubernetes. This is one implementation that has allowed us to start experimenting with the ideas to see where the problems are. It's in Apache 2, it's community-led. And we have providers now for Azure Container Instances, Alibaba Cloud, Elastic Container Instances, Hyper.sh, Amazon Fargate, VMware, and others. And it's a very vibrant community starting to think about how we build nodeless Kubernetes. So if you're interested, I invite you to come there and enjoy. I want to give you a little bit of an illustration about how this works. We have serverless Kubernetes API servers. For example, in the Azure Kubernetes service or in any other public cloud Kubernetes service, we have the serverless infrastructure. We have the virtual kubelet in between. It's just a process. The very first thing that it does is it registers a virtual node with the API server. It says, hey, here's a pretend node. It doesn't actually exist anywhere, but Kubernetes, you need to think about nodes, so here's a node. Eventually, I think we'll get to a world where the node actually isn't in the Kubernetes API or is optional in the Kubernetes API, but we're not there yet. And so for practical purposes, we need to inject that virtual node into the API server. At that point, the user comes along and says, hey, API server, I'd like to schedule a container. And then the virtual node says, oh, OK, container is assigned to this virtual node. The kubelet sees that that assignment has happened, the container has been scheduled, and the container is placed onto the serverless infrastructure. So the virtual kubelet at this point is really playing the role of mediator between the serverless container infrastructure and the Kubernetes API server. You can try this out today. It's a really fantastic way to get a sense for what serverless Kubernetes infrastructure, what nodeless Kubernetes infrastructure might look like. You can create an Azure Kubernetes Service cluster. You can install the connector that connects Azure Container Instances to the Azure Kubernetes Service via the virtual kubelet. And then you can just use Kubernetes as you had before. And it works exactly the same way that you would expect. And speaking of Azure Kubernetes Service, I have some important announcements about the service. So Azure Kubernetes Service is available in 15 regions around the world, and you can see the various green check marks in the various geographies. So we can deliver a worldwide solution for you, Kubernetes Anywhere. But you'll notice there's one region that is absent. And so that's why I'm excited today to say we're actually in 16 regions around the world, and that the Azure Kubernetes service is now available in China, in the Azure China region. It's in a private preview, but if you're interested in a managed Kubernetes experience, an experience where the operations are handled for you, you can now use that via Azure and the Azure China Cloud. So please go check that out, and you can even go use the virtual kubelet on it. Come see us at the booth if you want to talk about more. There's Learn AKS if you want to learn more about the Azure Kubernetes service. Here's a bunch of the open source projects that we work on. Thank you so much for listening, and I look forward to meeting you all later this afternoon.